Okay, so in this video, I'm going to do exercise 124, which is on a recursively defined sequence. So in a recursively defined sequence, you're given two things. You're given the first couple terms, A1, A2, A3 in this example, and then you're given a rule that tells you how to do the next term given the previous terms. And in this example, that is this thing. an plus 1 is an minus 2 divided by an plus an minus 1. And if you plug in different values of n, like 3, 4, 5, this equation is actually a whole sequence of equations. So for example, if you plug in n equals 3, when n equals 3, an plus 1 is a4, right, a4, and then an minus 2 is a1, right? 3 minus 2 is 1. So a1 divided by an is a3, and an minus 1 is a2. So this equation is true for all n, 3, 4, 5. In this case, n equals 3, so a4 equals a1 divided by a3 plus a2, this little guy over here. And when you have that, we know a1, 2, 3. We were told a1, 2, 3 over here. So we plug those in. a1 is 1, a3 is 2, and a2 is 1. 1 over 2 plus 1, which is 1/3. So a4 must be 1/3. So by using the initial condition, so sometimes this is called the initial condition, the IC, and the update rule, let's call this the update rule, you can get the next value in the sequence. And now that we know a4, we know a2, a3, a4, and so we can get a5 using the update rule. So the update rule a5, when n equals 4, n plus 1 is 5, n minus 2 is 2, so this is a2 divided by an plus an minus 1. It will be a4 plus a3. And a2, we said, is 1, a3 is 2, and a4, we just figured out, was 1/3. 1 divided by 1/3 plus 2, which is also, if you simplify it, 3/7. So you gotta do the fraction math, but it comes out to 3/7. Okay, last but not least, let's do one more example. When n equals 5, the formula says a6 equals an minus 2. An minus 2 is a3 in this case. An minus 1 would be a4, and an is a5. a3 divided by a5 plus a4. So in this case, a3 is 2, a4 is 1/3, and a5 is 3/7. And again, more fraction math, and you get 21 divided by 8. So this is an example of getting the whole sequence using the update rule and the initial conditions. This is really common in real life because sometimes in real life, the rule for the next term is simple if you know the previous terms. Like another example was the Fibonacci numbers we did in class, the sum of the previous two numbers. So this kind of thing comes up in a lot of situations. In particular, there's some financial applications where this happens, and that is in the notes. That's the next thing in the notes. If you're interested in this stuff, there's interest, simple interest, compound interest, and compound interest with withdrawals. And these are all situations where the amount of money you have or the amount of money you owe or whatever it is a simple equation in terms of what it was on the previous round. And then by chaining together this rule of what it was on the previous round over and over again, you can get all of the amounts. And we're going to get good at sort of finding the formula in some simple situations involving this stuff. Okay, I will stop the video there.